In this video, we will do a table example involving conditional probabilities. So the example says that the table below describes the course style preference for new SEU students. So this table, for example, in the rows talks about freshmen and transfer students, and then the columns talk about their preferences such as synchronous style or asynchronous or hybrid. And then we have these there's a total column at the end on the right and a total row at the bottom. So for example, for synchronous preference, there's 11 students who like that, who are freshmen, and there's 12 transfers who like that, and adding 11 plus 12 together gives us this 23. Okay, so the question asks, a person is randomly selected, find the probability that they are, part A asks, a freshman. So the first thing I'm going to do is I'm going to assign letters to some of these events. So for freshmen, I'll call that F. Transfers, let's call that T. Synchronous, let's call it S. Asynchronous, A. And let's call hybrid H. Okay, so we want the probability of F occurring that the student is a freshman. So to do that, we need to count the number of freshmen on top, divided by the number of the total possible outcomes. I'll just write the number of total. In this case, that's going to be the total number of students. So how many freshmen are there? Well, this thing says there are 25 total in that freshman row. And then divide it by there's 60 total students on the bottom. And I can simplify this by dividing the top and the bottom both by 5. In doing that, we get 5 on the top, and 60 divided by 5 is 12. So 5 over 12 is our probability. All right, so let's do a conditional probability. Part B asks a freshman, what's the probability that they are a freshman given that they prefer asynchronous classes? So let's write this with our notation first. So the probability that they're a freshman given, so vertical line, given that they prefer asynchronous classes, so A. So using our formula for conditional probability, we are going to need to count the number of elements in the intersection of these two, F intersected with A, and then divide that by the number of elements in A. Because that is our new sort of universe or sample space that we are limiting ourselves to, because we're given that we must be in A. All right, so let's interpret what these two things mean. So with this fraction on the bottom, the number of elements in A is the number of students who prefer asynchronous classes. I'm just going to write async. And on the numerator, I have to write the number of students who are in F as well as in A. So these are the number of people who are freshmen and they prefer asynchronous classes. So I'm going to zoom out a little bit so I can still see the table. Okay, so how many students are freshmen who prefer asynchronous classes? So I'm going to look at the freshman row, and under async column, there's 10 students like that. So how many students go on the denominator who prefer asynchronous classes? Well, in the async column, there are 24 total students like that. So 10 over 24. I could simplify this as well by dividing the top and the bottom, this time by 2. And doing that, I get 5 on the top and 12 on the bottom. So that's interesting. We're getting the same probability for the probability of this person being a freshman versus the probability of them being a freshman given that they prefer asynchronous classes. So the last part of the question I'm going to ask is, well, are these two events, freshman and prefers async classes, are they independent? So let's talk about this in two ways, actually. So solution 1 first. Okay, so as we saw in the last video, there are a couple of formulas I can use, either this one over here or this one down here, to check if my two events are independent. I'm going to start off by using the second one, just because I have a conditional probability like this already. Okay, so in solution 1, I'm going to check if the probability of f is equal to the probability of f given that A occurs. I'll put a question mark above my equal sign because I don't know if they're equal just yet. Okay, but we're essentially asking here, does A occurring affect the odds that f happens? Okay, and the nice part about this is we've already worked out both of these probabilities. So the answer to this is yes. Yes, these two events are independent because both of these probabilities equal, as we found out, they both equal 5/12. So f and A are independent. And that's interesting here because it's definitely not clear just from looking at this table why events like a student being a freshman versus them preferring asynchronous classes would be independent. So we'll see examples in later videos where we have two events, and it's going to be very clear from the context that those events will be independent. But when it's definitely not clear, like it is in this table, I definitely need to use an equation like this to verify mathematically, like, oh, does it satisfy the definition of being independent? And in this case, it does. Okay, so I also want to talk about a second solution. So what if instead I had used my other equation to verify independence? So I could have if I wanted to. We could also check if the probability of f intersected with A equals probability of f times the probability of A. And I'll put a question mark on my equal sign because I don't know if they're equal just yet. So I'm not actually going to work this out. But if we were to do it, we would get both of these sides are in fact the same. I just wanted to comment on the fact that we could do it this other way if we wanted to. So there's one last thing I want to comment on here, which is in solution 1, if I use conditional probabilities to check for independence, it doesn't really matter the order in which we do this. So here I had the f's in front. If I decided to put a's in front, that would also be fine. So we can also check if the probability of A equals the probability of A given f. So we could also do it like this. And I'll put a question mark above that equal sign. So in terms of our goals for this section, we finished our last goal, which is how to test whether two events are independent.